أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Necessary condition analysis using SmartPLS4. So what is a necessary condition and what is a sufficient condition? Now, necessary condition is something that must be present for a particular outcome to occur. Now, if you want to achieve an outcome, there are certain factors that must be there. Otherwise, you cannot achieve that particular outcome. Now, those factors, those conditions are called necessary conditions. Now, what is a sufficient condition? Now, this is something that, if present, guarantees the occurrence of a particular outcome. However, the outcome can still occur even if this condition is not present. Now, let's consider a test. Necessary condition. So, what is the necessary condition for passing a test? Studying is a necessary condition for passing a test. You cannot pass a test if you don't study. You won't pass the test. However, just because you studied doesn't guarantee you will pass. Other factors like understanding the materials also play a role. Now, what is a sufficient condition in this case? Getting every question correct is a sufficient condition for passing the test. If you answer every question correctly, you will pass the test. However, you could still pass the test even if you don't get every question right, but if you meet the passing threshold. So the sufficient condition is that you'd get some questions right. The necessary condition is, in order to get those questions right, you need to study. In order to pass the test, you need to study. So studying is a necessary condition. Hence, there are must-have and should-have factors. Necessary condition or necessary factors are must-have factors. Sufficient factors, sufficient conditions are should-have factors. Just remember, if your outcome cannot occur without a particular condition, then that is a necessary condition. Now, if your outcome can occur in the presence or absence of a condition, that is called a sufficient condition. Necessity logic implies that an outcome or certain level of outcome can only be achieved, must have, if the necessary cause is in place or is at a certain level. To express this necessity, what researchers do is that researchers refer to expressions such as X is needed for Y, X is a precondition for Y, X is required for Y, or Y requires X. Accordingly, the necessary condition being a constraint, a requirement, a bottleneck, a critical factor. Now, these terminologies you will see in papers on PLS, SEM and NCA. They must be satisfied to achieve the certain outcome. Now, other factors cannot compensate in a situation where a necessary condition is not satisfied. In necessary factors, those other factors cannot compensate for X, which is necessary for Y. Now, there are other important fundamentals related to necessity logic and NCA. Now, one thing that you will commonly see is this graph. Now, what it does is NCA reveals areas in scatter plot of the dependent and independent variables that denote the presence of a necessary conditions. Now, what happens is in this particular graph, what you have got is you've got a scatter plot of the dependent and independent variable, and this denotes the presence of necessary conditions. Now, while PLS SEM establishes a linear function, NCA covers a ceiling line or on top of the data. Now, this is your ceiling line here. Now, what this ceiling line does is it separates the area with observations, that is this area here, the area below the line. The larger the empty area is relative to the total area. So the larger this area is relative to this area, the larger the constraint that X puts on Y. So if you've got more empty area here and you've got all these under this ceiling line, and this area is relative, like increased in size relative to this area under the ceiling line, the larger is the constraint on X, or the larger is the constraint that X puts on Y. In such cases, X is an important precondition for Y. If you've got this area that is more white space, more empty space here. Now, there are commonly two default ceiling lines. One is the ceiling envelopment free disposable hull line, CEFDH. Another is the ceiling regression free disposable hull line, CRFDH, which is simple linear regression line that is going through the data points here, this one, this straight line. Now, which one will we use? We are going to talk about this later as well, but CEFDH, that is ceiling envelopment free disposable hull line, CEFDH, is recommended for discrete data. Now, CRFDH is recommended for continuous data. This is how the chart looks in SmartPLS. Now look at the white area. It's quite high. So this means that this particular X is putting a lot of constraint on Y. So X is a necessary condition for Y, as I can see from this particular chart. Now that chart can be presented in this form of bottleneck table that can guide us whether X is a necessary condition for Y and what level of Y can be achieved at the level of X. So what is the level of X so that you can achieve Y? A bottleneck table is another way to illustrate the NCA results. In such table, the first column, here it is. These two can be referred to as the first columns because this is Y in percentage and this is Y in actual values. Shows the outcome. These are the two outcomes, or rather the outcomes in two different formats. While the next column represents, and any additional column represents the conditions, that is X here. These are the conditions that must be satisfied to achieve the outcome, that is Y. Now the conditions represent the necessary levels of the independent variables for the outcome. Now look at this. These are the necessary levels to achieve this level of outcome. Now let's say if I want to achieve 50% of the outcome, that is 4, level 4 is 50% of the outcome. I need my X to be at least at 3. Now what does this mean? We are going to come to that later. So if I've got 1 X, 1 Y, what is the level of X that I need to achieve at least 50% of my outcome? That 50% in actual values is 4. So I need my X to be at 3. Now, what does this NN indicates? NN means not a necessary condition. Now, in order to achieve 1, 1.6, 2.2, 2.8 level of the outcome, that is 30%, you do not need any X. So X is not a necessary condition up until 30% of Y or 2.8 of Y in actual values. Now it also lists the percentages here, which we have explained that the first column lists the percentage ranges for the outcome. It expresses the values of Y in percentages of their ranges, in which 0 is the lowest level or lowest observed value and 100 is the highest observed value. Now for instance, again we have already mentioned, if you want to achieve 50% of the outcome, you need your X to be at this particular level. Moving on. Now, in addition to these other columns, table X in counts, the fourth column, in percentiles in the fifth column. So this is X in counts, X in percentiles. Now, what does this mean? Displaying X in the bottleneck table in the form of counts focuses on the number of cases, that is the observations that do not meet the necessary level of X to accomplish the certain level of Y. So, for instance, when considering an outcome level of 5.2, where is 5.2? Here it is, 5.2, 70%. You need your X to be at least 4.5. And in this case, we find that 20 cases do not achieve the necessary level of X. Here it is. So when achieving or when trying to achieve 5.2, your X is at 4.5, and the data that this particular example uses, 20 cases do not achieve the necessary level of X. Now similarly, what does percentile means in this case? Now the percentile option displays the percentage of cases that do not meet the necessary level of X to accomplish a certain level of Y. Now I'm going to take the same example here. We see that, for instance, that 20 cases that did not achieve the level of 4.5 here, 20 cases did not achieve this level of 4.5. They correspond to 33.3% of all cases. If something is necessary, what's its effect size? Now that is referred to as D, and its significance, which indicate whether a variable or a construct is a necessity condition or a necessary condition. The value of D is calculated by dividing the area without observations, that is above the ceiling line, by the total area that contains or could contain observation, that is scope, as per the boundaries outlined by the minimum and maximum theoretical or empirical values of X and Y. Thus, by definition, D ranges from 0 to 1, where higher value means higher effect or large effect, and low means low effect. So something between 0 to 0.1 is a small effect, 0.1 to 0.3 medium, 0.3 to 0.5 large effect, and over 0.5 is very large effect. Now, previous studies have used the threshold of 0.1 to accept the necessity hypothesis. Thus, an effect size of 0.1 and higher is required to consider a variable a necessary condition. However, the absolute magnitude of D only indicates the meaningfulness of the effect size from a practical perspective. Now, accordingly, researchers should also evaluate the statistical significance, the p-value, whether that effect size is significant or not. And if it is, then necessity hypothesis is substantiated. Now here are the steps for NCA. Now the steps remain the same as you do your measurement or structural model. So what you have done previously, you have to obviously have your research background, objectives, prepare the data, clean it, put it in SmartPLS, assess the measurement model. Everything remains the same. What we have done previously, there are videos on the channel to do all these steps. Once you have assessed the measurement model, then comes into play the necessary condition analysis. The next step is now we are going to perform the necessary condition analysis. Now step 5 is to generate the scores or extract these scores. Now in our example, what we have done is we have got a Likert scale from 1 to 7 with 1 meaning low ratings for all the indicators. Now in our case, all indicators are measured on the same scale. The interpretation of the unstandardized latent variable scores is straightforward, which would not be the case if differently scaled indicators were used. Now if you have used differently scaled indicators, then use standardized. Otherwise, use unstandardized latent variable scores for NCA. Now both standardized and unstandardized latent variable score will produce the same NCA parameters. However, the bottleneck levels will differ owing to different scales that are involved. However, with unstandardized, the interpretation is easier if you have used the same scales. Now, one important thing, the NCA or the NCAs are performed individually for different outcome variables. Now, if you've got multiple outcome variables, you need to do multiple NCA analysis that is separate for each DV or dependent variable. Let's start the NCA analysis, and as we do, we are going to read these slides along with our results. Now let's suppose this is the model that I'm interested in testing my organizational performance based on these 7 predictors. Now again, the previous steps or the preliminary steps, I've collected the data, I've put it in a software, I've cleaned the data, then I imported the data into SmartPLS. Now I will assess it for measurement model. For now, let's use the standardized start calculation. Now I have assessed the outer loadings. I have assessed the reliability and validity. Everything fine. I have reported my reliability and validity. Now once this is done, now I am going to go for necessary condition analysis. So how do I start? Let's go to calculate PLS SEM algorithm. Since I have used these scales that are same for all the constructs in the study, and this is discrete data. 1 meaning low rating or strongly disagree, 7 meaning strongly agree. Now I'm going to use unstandardized type of results. So what I'm going to do is I'm going to press start. Now latent variable scores. Now these are the scores that I'm going to use for my necessary condition analysis. So I'm going to create the data file. I do not need the manifest variables. I just need the latent variable scores. That is these scores for my necessary condition analysis, nothing else. And I'm going to call it, let's say, unstandardized and create. Let's go back. Here is my data file that is created. Now, how do I do necessary condition analysis? Make sure your project is selected. You can click here, or you can just simply right click on your model and do, or rather your project, and do new regression model. And let me call it NCA, necessary condition analysis, in my first model, and that is regression. And let's save it. Now, what is my outcome? Here is my outcome, organizational performance, Y. That is my Y. Here it is. Now you can put the intercept wherever you want. Let's say it is here. Now I've got my 7 conditions that I want to assess whether they are necessary or not. So I'm going to drag them and drop them onto my dependent variable. Here it is. Let's bring them here. And here it is. Now, in order to run the necessary condition analysis, what I'm going to do is I'm going to click here, calculate necessary condition analysis. Click here. Now, we are going to use the defaults, although you can change these as well. Now, this actually what it does is it changes the percentages in the outcome or the bottleneck table. For now, we are going to keep it as 10 and click, make sure that open report is checked and press start. Now here is your ceiling line effect size overview. So what is the effect size here? Well, it is a necessary condition. It is a necessary condition. Well, this doesn't look like a necessary condition. This one is a necessary condition, doesn't look like a necessary condition. And same is the case on this one, might be a necessary condition as well. Now I'm not using CRFDH because my data is a discrete data. The original scale on which I collected my data was discrete, 1 to 7. So I'm going to use ceiling envelopment full disposable hull line, this one here. Now, is this significant? How would I know if this is significant or not? To do so, what we are going to do is we are going to come back here, go back. You do not get to see the significance if you run just the necessary condition analysis. You need to run NCA permutations. Now, the required is 10,000 permutations. Start, make sure open report is selected, start. Now here it is. For CEFDH, look at this. Is it significant? Yes. Significant? Yes. Significant? Yes. Yes. No. Assurance is not a necessary condition, is not a significant necessary condition, whereas these two again are significant and necessary conditions for the outcome to occur. This is how you get the p-values for your effect size. Now we need to understand the level of outcome that we want to achieve and how or what will be the value of X in order to achieve that outcome. So for that we need our bottleneck tables. Where are the bottleneck tables? Again, NCA, or here is necessary condition analysis results. And I'm going to open the report And where are my bottleneck tables? Now look at the corner tables here. So the level of X to achieve the level of Y. Here it is. It's for each of your predictors. So it's a bivariate technique. So to achieve the level of 7 for my organizational performance, I need my responsiveness to be at least 2.638. If you look at here, this one, 2.638 is the same as what we saw in the corner tables. Now, what does this bottleneck table mean? Now, look at this vision. In order to achieve the level 1 of organizational performance, none of them are necessary. Now, they are not necessary up until here. There is no condition that is necessary up until 30% of organizational performance. Now, if you want to achieve 40% of organizational performance, that is OP at the level of 3.4, only one of them is a necessary condition. All others are not necessary. Now, if you want to achieve 50%, only two are necessary. This one and this one here. Now, if you want to achieve 60%, that is 4.6 organizational performance, level of organizational performance, these fours are necessary conditions. These two are not required. Now, if you want to achieve 100% of your organizational performance, that is level 7, you need your vision to be at this level, your development to be at this level, your rewards to be at this level, your reliability to be at this level, your assurance to be at this level, your empathy to be at this level, and your responsiveness to be at least at this level. So this is how you interpret your bottleneck tables. Now these are the values. Now these are, the next one is counts. Now 15% of the cases failed in this case. And this is the percentiles as explained earlier. Now 4.39% of the cases failed to achieve this level of outcome. And this actually represented 15 cases. Now here are your charts. Now look at this. There is very little space here. Look at this. See, rewards, very little space here. Now what does this mean? Let's come back here. Now if you look here, in this case, the larger the empty area is relative to the total area, the larger is the constraint that X puts on Y. Now in this case, look at this. The empty area is not large enough. So is rewards like a very significant and necessary predictor of Y? Look at this, rewards. No. Look at the empty area. Look at the highest value. Let's say development. So look at the development chart here. The empty area is quite large in comparison to the other ones. Moving on, the rest is not required. So this is how you look at the results. Now let's evaluate our structural relationships. Now the same process that we have done earlier in the previous sessions. Look at the VIF values, look at the R square, look at the significance of relationship, look at the PLS predict or the Q square. Now once all this is done, then we report our necessary conditions. Now for structural relationship, you simply run the bootstrapping technique. And for VIF, obviously you will get it from PLS SEM. The R square, PLS SEM. For PLS predict, there is a separate analysis that you can do. If you go to calculate, okay, now not here, PLS predict won't run here. You have to have your full model. So there is a video on the channel that will be shared in the description. Now, once the structure model is done, once you have reported all these, the next step is you go for your necessary condition analysis. Now we need these structural relationships in our reporting of results as well. So let's get the results. Here is my model. Now go to calculate. To get VIF values or R square values, you can run PLS SEM algorithm. To get significance values, we are going to run the bootstrapping technique. Let's do standardized 10,000 All good. Let's start. Now here are our results. Go to path coefficients and here are the results. Now I'm not interested in all of them. I'm just interested in the impact of those 7 conditions on organizational performance. So you can copy it to Excel. Now here I've got a sample here, but let me create one for you. So delete all else apart from those factors affecting OP. Delete. All good. Yes, I'm not interested in this. Let's put this one away. Now I've got these beta coefficients and whether they are significant or not. Select them, right click, format cells, number 3. Okay. Let's save it. Now that I've got these results, I need my effect size and whether that effect size is statistically significant or not. The next step, let's get those. Go back, NCA, calculate, NCA permutations. All good, start. Now here are the effect sizes and the permutation p-values. Let's copy them to Excel, paste it. Do not need this column for now. Right click, format cells, number, 3 decimal points. Okay. Now vision here, development here, rewards. So you see that these factors are in line. Now the bottleneck tables, apart from this, that are generated provide relevant levels of these antecedent constructs that are necessary to achieve the specific outcomes. Now you are going to use those bottleneck tables that we saw earlier. Here are they from necessary condition analysis. All good, start. This one, this table. This will tell you the level of outcome that can be achieved based on these conditions and whether or not they are necessary or not. So you are going to present this table in your analysis results as well. Now, how do we interpret these findings? So what if your exogenous construct is significant here in PLS SEM results and it is a necessary condition? Look at this. It is significant. And is it a necessary condition? Yes, it is. So how do I interpret this? To do so, I've got this template here. Now, what does this mean? On average, an increase in the exogenous variable. What is my exogenous variable here? Vision. So on average, an increase in vision will increase the outcome, that is the performance. However, a certain level of, where is my bottleneck table for vision? Look at this here. A certain level of vision, here it is necessary for the outcome to manifest. Now, in order for outcome to be manifest, to be observed, you need a certain level of vision. Now, what happens if your predictor is significant, but it is not a necessary condition? Look at this. In this case, we do not have that. But what if that happens to you? This means that an increase in the exogenous construct will increase the outcome. However, no minimum level of the construct is needed to ensure the outcome because it is not a necessary condition. So there could be other scenarios as well. Now what I've done is, before I move on to that, let me explain these bottleneck table once briefly. Now this is the bottleneck table. Let's say I want to achieve 80% of organizational performance, not loyalty, that's a typo. Your vision must be at least 2.150, which we have explained earlier. The development must be at this level. The rewards must be at this level. So this is how you explain your bottleneck tables, which we have already done. Now we have done percentiles as well. Increasing the percentile offers further insights. We see that, for instance, for 4.399%, that is 15% of the cases, did not achieve the required understanding of vision. for a 80% of performance. For 80% of performance, 4.399% of the cases, this amounts to 15 cases, did not achieve the understanding of the vision. Now what I've done is I've used this table here, the results table, along with this table here, and I've created this table here. And you can see this table here as well in the scenarios. So what happens is these are the scenarios. I've got 4 scenarios here. Exogenous construct is a significant determinant. So I've got which ones are significant. This one is significant, this one is significant, this one is significant. So I've got 3 significant here. And I've mentioned those 3 here: vision, development, and responsiveness. And are they necessary conditions? Let's see. Yes, this one is necessary. Yes, this one is necessary. And yes, this one is necessary as well. So these 3 are significant and necessary as well. So I've put them here. So both have to be significant and necessary. So you will put only those predictors that are both necessary and significant. What's the conclusion? On average, an increase in the exogenous construct will increase the outcome. However, a certain level, that is the C and CA bottleneck tables, of the exogenous construct is necessary. So if you look at your bottleneck tables, there is a certain level of vision that is required for your organizational performance. So what is that level? If I want to achieve 80% of my organizational performance, I will need vision. I cannot achieve 80% of my performance if I do not have a vision. Moving on. So how do I interpret based on the example? On average, an increase in the vision, development, and rewards will increase the performance. Also, to achieve performance, there needs to be certain minimum level of understanding of vision, focus on development, and responsiveness in employees. Otherwise, you cannot achieve a certain level of performance. Now, there is another scenario. Your PLS SEM results are significant, but it is not a necessary condition. Is that a case in your results where your PLS SEM are significant and it is not a necessary condition? So I've got 3 significant here and all 3 are necessary as well. So that is not applicable in my case. So I've got, look at this, significant determinant but not a necessary condition. These are significant and are necessary conditions. So there is nothing on the second level here. What if I've got non-significant determinant but a significant or a necessary condition? So I've got a non-significant determinant here, but it is a necessary condition. Non-significant, a necessary condition. Not significant, a necessary condition. So I've got 3 here. OP, rewards, reliability, and empathy. Rewards, reliability, and empathy. Their D value and their P value from permutations, and how do you interpret it? A certain level, that is, you have to see the bottleneck tables of the exogenous construct, is necessary for the outcome to manifest. A further increase is not recommended since it will not increase the outcome any further. So you need to achieve a minimum level of the predictors. Increasing it further will not help you in increasing the outcome. To attain organizational performance, there needs to have a certain minimum level of rewards, reliability, and empathy. A further increase of rewards, reliability, and empathy in the organization will on average not further increase the organizational performance. So you need the bare minimum level of those factors to achieve the outcome. Further increasing those conditions will not help in achieving organizational performance. And finally, when your PLS SEM results are insignificant and it is not a necessary condition, that is the case with assurance. Where is it? Look at this, assurance. Insignificant, insignificant. So it is neither significant nor a necessary condition. Assurance is neither a must-have or a should-have factor for the improved organizational performance. So this is how you can present your results to the reader in your paper, along with the bottleneck tables. But there could be a condition where, or there could be a situation where the condition is actually not necessary. So what currently SmartPLS software does is that it only tests whether the presence of an antecedent construct is necessary for the presence of Y. So whether X is required for Y or not. Now theoretically, there may be other forms of necessities that can be formulated, such as the absence of an antecedent construct or condition that is necessary for the presence of the outcome. So you need the antecedent or the predictor to be absent in order for the outcome to occur. For example, abusive leadership. For example, toxic leadership. Or there could be other variables as well. Necessary condition analysis is not limited to situations where the presence of a condition is necessary for presence of an outcome, but it can also be applied to different combinations of both presence and absence of conditions for an outcome to occur. So you may have some variables whose presence is required, and you may also have some constructs whose absence is required for an outcome to occur. Now, what happens? How do you do it? Now, to test other combinations, you will need to flip the coding of your scales. Thus, researchers need to ensure that coding of their variables corresponds to analytical procedure. Now, here the analytical procedure guides how you code your variables. Now, previously, what we used in the last example was variables where low score means lower perception, low rating, and higher scores meant higher rating or better perception of that particular variable. Let's say vision. So higher score meant higher perception, higher understanding of vision. Higher score on rewards meant better rewards. Now in this example, if let's say we have constructs like role ambiguity or role conflict, they are measured on 1 to 7, where low means low role ambiguity and high means high role ambiguity. Now in such cases, you will need to flip this coding. You would most likely to test the necessity of absence of antecedent constructs. Now I'm trying to find whether the absence of role ambiguity and or role conflict can lead to better organizational performance. Now in this case, what we need to do is we need to test the absence of these constructs. Now to test the absence of these constructs in order to lead to organizational performance, I will flip this role ambiguity or role conflict construct. Where when I collected data, it meant 1 for low and 7 for high. But now when I flip it, 1 means high role ambiguity, 7 means low role ambiguity. So higher score on role ambiguity means absence of role ambiguity. So how do I do it? First, let's say I've got data in SPSS, and what I need to do is I need to flip these two variables, 5 items for role ambiguity, 6 items for role conflict. How to do it? You need to go to transform, recode into different variables so you have your original data intact. Now how to use this? I've got a video, I'll share it in the description. You watch it and I will have my transformed score here. Now once I've got the transformed score, make sure you save your file. I've already saved it, and then we import it in SmartPLS. Import data file. Here is my file. And I'm just going to make sure I've got my data here. Here it is. 1 to 7. Import. Now here is my measurement model, and I've got, let's say I have to put the role ambiguity. Let's say I've got 1 here. Role ambiguity. Added. Let me hide the indicator. Alt X. Connect it. Now save it. Let's go to PLS SEM algorithm. Unstandardized. Start. Now look at the latent variables, and we need these scores. So what I'm going to do is I'm going to create a data file, just the latent variable scores, and let me call it unstandardized. Create. The data file is created. Go back, and now let's say click here, regression, and let me call it NCA. Save. OP is my dependent variable, and all others are my predictors or the conditions that I think are necessary for the outcome to occur. Drag and drop it onto your outcome, and here are all your predictors that some of them may be necessary, some of them may not be necessary. So how do I check it? Go to calculate, necessary condition analysis, all good, start. Now effect size, well, role ambiguity, very weak. Let's see the bottleneck table. Well, it only becomes a necessity or necessary condition at 100% of organizational performance. But I want to find out whether it was significant or not. So go to calculate and see a permutation. Okay, 10,000. And let's start. Here it is. Well, it's not a necessity or a necessary condition for the outcome to occur. So this is how you can use a condition that requires to be absent for an outcome to occur. Now moving on, what if your scores are reflective and formative? Now for example, we've got combination of reflective and formative constructs in our model. Now previously the examples that we discussed only had reflective constructs. What if your constructs are formative? Now in order to deal with formative constructs, what needs to do is that, let's look at this. For PLS models, reflective constructs, we recommend focusing on the latent variable score. So if your constructs are reflective, you only focus on latent variable scores from PLS-SEM. Now for formative constructs, we recommend focusing on the latent variable scores in case of endogenous constructs. Now if your construct is endogenous, only use the latent variable scores, as the objective is usually to explain and understand relation to the construct. So you want to explain the outcome and how the factors influence the outcome, whether they are necessary or not. Now, what if your constructs are exogenous and they are formative? So for exogenous constructs, it is recommended to include the latent variable scores and the individual indicators. So use both latent variable scores and the individual indicators, as we may want to complement the analysis on the construct level with analysis for the individual indicators. Now, what happens in formative constructs is that individual items form a construct. So we want to find out whether as a whole the construct is necessary or whether individual indicators are necessary. Now, if one or more exogenous constructs are formative, we recommend running additional analysis using single indicators of the formative constructs. Now, if you've got exogenous constructs as formative, use single indicators and the whole construct as a predictor as well. Now, therewith we can test whether the individual indicators forming the construct are necessary condition or just the individual items are necessary. Now, I've got an example here. This is my measurement model. And in this example, what I have here is, now this is my higher order construct. Now, I've got a higher order construct, internal marketing, that is made up of 3 subdimensions. These are reflective constructs. This is reflective as well. Now, these are the subdimensions for a higher order construct, but for now they are reflective. At lower level, they are reflective. So what I'm going to do is, let's go to calculate. Now, all the other steps remain the same. those steps that we discussed in the first session on necessary condition analysis. The link will be shared in the description. Those steps remain the same. You have to assess the measurement model, reliability, validity, and all those quality criteria have to be assessed. Unstandardized, all good. Let's start. Now, latent variables, create data file. Now, in this case, I will need manifest variable scores for now. So I'm not going to use the other ones. I'm just going to keep these two, and I'm going to call it unstandardized. So I've already got it, so I'm just going to use it. Override. Now go back. Now I'm going to go to this model. Now this is the same model as earlier one. I've got IM as a higher order construct now. So for now, let's delete it. Here it is. And vision, development, and rewards. Now these were reflective constructs previously. Now they are items for higher order construct of IM. And they are formative, right click, invert measurement model. Now connect it. Hide the indicators. Now what I'm going to do is I need latent variable score for this now. So because I've got this as formative, so I need latent variable scores both for my lower order constructs and the higher order construct that is made up of the lower order constructs. Calculate PLS SEM algorithm. Unstandardized data, start calculation. Now create data file. But I need the individual scores from the previous analysis, the latent variable scores as well. So I'm going to keep this manifest here. I'm just going to create. Now go back. Now we are going to do our necessary condition analysis. So regression and call it NCA. Save. Now, where is my DV? Here is my DV. Put it in here. Now, where are my individual variables? So first of all, I'm going to do it on the individual indicators that make up the higher order construct or higher order formative construct. Now, these three make up IM. So I'm going to just put each one of them and CC. Let's say I need OC as well. Drag and drop them here. So here are my variables. Now, calculate necessary condition analysis. Now the process remains the same as we have done earlier. The interpretation remains the same. Let's look at it. Bottleneck table. So all of them start to be necessary conditions when you reach 80 or when you want 80% of organizational performance. So this is easier to interpret. We have already done it before. Now, which ones are significant? NCA permutation. Let's do 10,000 quickly. Now, all of them are significant. Now, let's go back and let's do one more thing. So, I want to find out about IM as well. So, let me copy it to Excel because I want to compare something here. Now let's go back here. And where is IM? Here is IM. So I'm going to put IM in the same model for now because I want to check something here. So now let's go to calculate and see permutations. Start. Copy to Excel and let's paste it here. Now look at this. Look at the effect size. The same as previously, because if you remember, we did it in the first session that it is a bivariate technique. This is the inclusion of IM. So with the inclusion of IM, the other values did not change because it is a bivariate technique. So each of those antecedent conditions are assessed whether they are necessary for the outcome or not. So the inclusion of other variables does not influence the previous values. So this is how you can use necessary condition analysis if you've got formative indicators or formative constructs in your study. Thank you very much.